Testing of material laboratory with universal testing machine. Surveying laboratory. Testing of material laboratory with universal testing machine. Technology laboratory. Surveying laboratory. Fluid mechanics laboratory. Testing of material laboratory with universal testing transportation engineering laboratory. Environmental engineering laboratory. Fluid mechanics laboratory. Testing of material laboratory with universal transportation engineering geology laboratory. Environmental engineering laboratory. Projects in the field of structural engineering, water resources, environmental engineering, concrete technology, transportation engineering. Projects are industry sponsored based on societal needs and technical solution to real life problems. Students enthusiastically exhibit their project in front of experts. Such platform boosts their confidence. Strength of department is strong industry institute interaction, Center of Excellence by Dr. Fixit in the department. Also, department has introduced new elective retrofitting and rehabilitation of concrete structures at SPPU. Benefits of industry institute interaction to the students are sessions by industry expert, training programs, workshops, seminars. Civil engineering cannot be learned in four walls of classroom. Hence, the department provides internship program to students and ensures that every student do it effectively. Some of internship platforms are Pune Metro, BAI, L&T, Shivke Constructions. During this COVID pandemic, department has provided online internship to the students, placement in core companies and software companies as per students' interest. Learning by involvement is the best technical knowledge. Teamwork and communication, presentation skills, model exhibition. To keep the pace with advanced technology, software training are conducted regularly. Site visit to construction site, airports, water treatment plants, dams are conducted regularly. The department has established international student chapter with ASCE, Institute of Engineers India, CESA, Civil Engineering Student Association, Srishti, an Environmental and Social Awareness Club, Antram, a cultural club, students also participate in NSS activity. Students and faculty make us proud by winning awards at international and national levels. Alumni are successfully working in PWD, Central Railways, PCMC, Water Resource Department, MS from reputed foreign university, MTech from IIT, NIT, and also successful in private sectors. Civil Engineering at Dr. D.Y. Patil Institute of Technology, Pimpri, a step towards excellence. Dr. D.Y. Patil Institute of Technology, Pimpri, is ranked in first 200 colleges in India, fourth in SPPU by NIRF, NAC, A-grade institute with all programs MBA accredited. Civil Engineering offers UG with 120 intake, PG in Construction Management, PhD in Research Center affiliated to SPPU. The department is endowed with high caliber team of professionally inclined faculty members. The department has state-of-art infrastructure and well-equipped laboratories like testing of material laboratory with universal testing machine, surveying laboratory, fluid mechanics laboratory, transportation engineering laboratory, environmental engineering laboratory, engineering geology laboratory, projects in the field of structural engineering, water resources, environmental engineering, concrete technology, transportation engineering. Projects are industry sponsored based on societal needs and technical solution to real life problems. Students enthusiastically exhibit their project in front of experts. Such platform boosts their confidence. Strength of department is strong industry institute interaction, Center of Excellence by Dr. Fixit in the department. Also, department has introduced new elective retrofitting and rehabilitation of concrete structures at SPP. Benefits of industry institute interaction to the students are sessions by industry experts, training programs, workshops, seminars. Cannot be learned in four walls of classroom. Hence, the department provides internship programs to students and ensures that every student do it effectively. Some of internship platforms are Pune Metro, BAR, L&T, CK Constructions. During the COVID pandemic, the department has provided online internship to the students, placement in core companies and software companies as per students' interests. Learning by involvement is the best technical knowledge. Teamwork and communication, presentation skills, model exhibition. To keep the pace with advanced technology, software training are conducted regularly. Site visit to construction site, airports, water treatment plants, dams are conducted regularly. The department has established International Student Chapter with ASTE, Institute of Engineers India, CESA, Civil Engineering Student Association, Reddy, an Environmental and Social Awareness Club, Andhra, a cultural club. Students also participate in NSS activities. Students and faculty made this proud by winning awards at international and national levels. Our alumni are successfully working in PWD, Central Railways, PCMC, Water Resource Department, MS from reputed foreign university, MTech from IIT, NIT, and also successful in private sector. Civil engineering with Dr. D.Y. Patil Institute of Technology, simply a step towards excellence.
Good morning, all. I, Mrs. Ashwini Sarunkhe, welcome you all in 1 week ATAL FDP program on recent development in construction technology, addressing infrastructure and coastal engineering, organized by Dr. D.Y. Patil Institute of Technology, Pimpri. The program will start in 5 minutes. I will request participant to uh, mute your uh, mute your mic. As soon as our resource person join, we will start the session on time. All participants
Hello, madam. Hello, madam. Good morning.
Yes, sir. Good morning.
Madam, yesterday I sent HOD that Deepa madam the mail, actually the first day on the 9th August. Okay. The
Yes.
last third session, I was there. I continuously first, second day throughout the session, first, second, third, all the sessions I am present and it is recorded. Only thing
Okay,
is
sir.
that in the
Okay.
first day
Huh.
submitting the feedback, I faced the network issue, so I could not able to submit the session 3 feedback of the first day, that is the 9th August, and I communicated to mail the Deepa madam also, but
Okay.
not
Okay.
yet got the feedback, madam. So that's why I'm telling whether it is acknowledged or
Y-
not.
Yes, sir. Yes, sir. I will talk with my technical team and will personally mail you, sir, or message you. Okay, Sarkar,
Thank
sir. Okay. Yes,
for
sir. Is that okay?
thank you for your favor, ma'am. Thank you. Thanks a
Yes.
lot.
Yes. Okay. Thank
नाही सर सॉरी चुकून झालं होतं तुम्ही दुसऱ्या सेशन मध्ये
Good morning, all. Welcome, Muni Reddy, sir.
Good morning, Muni Reddy sir. Welcome you for the today's session. Thanks for joining, sir. Sir, you are not audible. Sir, you are not audible, sir.
Yes, he is connecting to audio. Yes, he's connecting.
Good morning, Joshi madam.
Yes, sir. Yes, sir. Good morning.
Good morning, sir. Shall we start, sir?
Yes.
Yeah. Good morning, all. I am Mrs. Ashwini Sarunkhe. Welcomes you in 1 week ATAL FDP program on recent development in construction technology, addressing in infrastructure and coastal engineering, organized by Department of Civil Engineering, Dr. D.Y. Patil Institute of Technology, Pimpri. Now I request Ms. Kshitija Tikhe madam to introduce our resource person.
Thank you, Ashwini ma'am. A very good morning to one and all. It's my honor to formally introduce our guest of today's session, Dr. M.G. Muni Reddy sir. Dr. Muni Reddy sir is currently associated with Department of Civil Engineering, Andhra University, Visakhapatnam. He is PhD from Department of Ocean Engineering, IIT Madras in the year 2005. He has guided 6 PhD and 17 MTech scholars. He was a visiting assistant professor at Asian Institute of Technology, Bangkok, Thailand in the year 2011, deputed by Department of Higher Education, MHRD, Government of India. He has visited Dubai and Sri Lanka under COPEDEC fellowship with an assistant of DST. He has completed 2 R&D projects sponsored by CSIR Delhi and UGC Special Assistant Programs. He organized international webinar on climate change impacts on water resource management and environment and national FDP on environmental resource management towards sustainability from 24th of July 2020. He also conducted 2 short-term training programs sponsored by DST New Delhi for faculty, engineers from local government organizations and practice engineers. He is also a resource person on coastal disasters and vulnerability for Andhra Pradesh Human Resources Training Institute and UNDP training programs in Visakhapatnam. He was awarded as Distinguished Scientist in Coastal and Marine Engineering by Venus International Foundation in the year 2017. Shiksha Gaurav Puraskar 2019 was given by Center of Education Growth and Research, New Delhi. Academician of the year 2019, a National Leadership Award was given by Integrated Chamber of Commerce and Industry. Early Faculty Induction Program, a latest search program for identifying the potential faculty members in civil engineering selected by AICT New Delhi. Local Coordinator for Coastal Erosion and Sustainability Shoreline Management of Visakhapatnam. We are very much fortunate to have such an eminent personality with as a resource person. With sir's permission, may I request all the participants to switch on their videos for a group photo.
Is it done, ma'am?
Just a second, ma'am.
Okay. Thank you. You can switch off your videos now.
Thank you, everyone. I request Muni Reddy sir to please start with our today's session.
So now you can share the screen and PPT.
Good morning.
Good morning, sir.
Can you hear me? Am I clearly audible?
Yes,
to-
sir.
So you are audible, sir.
So my screen, I shared the screen.
Yes, it is visible.
Okay. Then let me check 1 or 2 slides. The slides are changing.
Yes, sir, it is changing.
Oh, fine, good. Okay. Good morning to all of you. At the outset, I would like to place my sincere thanks to the management of DPU and especially the coordinators of this ATAL FDP program and the HOD Civil Engineering Department, Patil Institute, DPU. Thank you very much giving me this opportunity to be with you this morning to share some of my thoughts, whatever I have learned through the years, theoretically and in the field experiences. So, now shall I start now? I'm clearly audible to all of you.
Yes, sir, you can.
Yes, sir.
Okay. So today's my topic is on coastal erosion and protection structures. I try to connect a little bit with the climate change scenarios. This is a part one, and time permits. I have a little bit different presentation with coastal reservoirs in part B. So it may be this session may be, I think it is 10 to 12, right? Okay, for the last couple of days, you may be listening to a lot of things about coastal, especially the ocean interface with the land surface. That is what we normally called as a coastal area or coastal line, shoreline. There are many different terminologies to understand that. So the coastal erosion is a topic. It will have its own definition for different perspectives of views. Somebody looking at structural point of view, somebody looking at oceanographical point of view, somebody looking at morphological point of view. So for everybody, this definition has its own. This term coastal erosion has its own definition. So now the moment you say the coastal erosion is a loss of material which you allow unattended, it will also have an impact on its surrounding areas because it will happen on the shoreline. Shoreline is, I told you, it is interface between the huge water mass and the land mass. And most of our habitation settlements will be along the coastline. So that slowly progress, this coastal erosion slowly progress towards the habitations and coastlines. So I think Pune may not be having the coastline, but I would like to welcome all of you to my city. It is called the City of Destiny, Visakhapatnam on the east coast of India in the state of Andhra Pradesh, where we have a strategic naval establishments of the government of India that is known for it. And the second point is it is a natural harbor. It happened naturally, so it is also another point where the city has been remembered. Okay. So this is outline of my presentation. So a little bit about the coast, some basic principles, coastal hazards, managing the coast. I'll also touch upon some of the field scenarios what we have been dealing with the various government agencies and funding agencies, and also our field studies from our department. And little bit this about coastal reservoirs, a new topic, new concept, unlike to our conventional reservoirs. Recently in 2019, we have a international webinar on this coastal reservoirs. That also I would like to stress upon that. So to see at our Indian coast, this is general information. It in the largest coastline, and we have a total population within the 100 kilometers, 40% of the population. This coastline is ecologically very sensitive. We have all type of ecological features: mangroves, tidal flats, coral reefs, turtle breeding grounds. Olive red turtles are famous for in the east coast of India along this Andhra coast, and we have a salt lake. So along this coastline, we have a very sorry, many exclusive economic zones. So in Visakhapatnam itself, we have so many industries, especially the apparel industries, pharmaceutical industries, and then HPCL, we have petrochemical industries, major ports. And we have this also our coast, especially compared to West Coast, East Coast is a little bit less in attracting tourists. And do we have also beaches? But our beaches are very rough and our coastline is very rough compared to the West Coast. West Coast is very smooth. The beach slopes are very mild. So we have a very important establishments, ports and harbors. Then we have oil and gas, tourism, coastal industry, shipping, power plants, renewable energy systems, desalination. And our India is also 9 coastal states and similarly 4 UTs. Right. So it is about general information on this our coastline. So the moment you say the coastal engineering or in a civil engineering background and who want to deal with the coastline or the interaction of the sea with the landmass, he should have some basic background knowledge on what are the processes that has been happening on the coastline. So what we normally call as a coastal process and landforms. So these are basically classified into, if you look at physical oceanographical perspective, we have erosional and depositional landforms of coastal areas. So all these landforms basically are the result of the action of the waves. The moment you say the ocean or sea, the surface phenomena is predominantly waves, what we know as, there are different types of waves. Normally, as an engineer or civil engineer who is looking at the coastal infrastructures, I am always concerned with the gravity waves. These are also called wind generated waves. Wind waves are gravity waves. Okay. So there are some erosional and depositional forms. It looks like physically here because of the waves are continuously happening. Unlike the water surface in the dams or reservoirs, water surface in the sea or ocean is a dynamic in nature, is a dynamic free surface. It has its own deformations or deflections or oscillations with respect to space and time. So the moment you say the waves are moving, so it has a lot of energy in terms of kinetic energy and potential energy. So all this, the energy which is being carried by the waves, gravity waves predominantly, so will have impact on the coastline, landmass. So this coastline may be rocky coastline or it may be sandy coastline. So East Coast, if you see, majority of the coastline and the rocky in nature. So rocky means there are hard surfaces, rocks, outcrops, and there are some vertical cliffs along the coastline. But whereas West Coast is very smooth and plain forms. Then these are the depositional landforms where we have so much this type of formations along the coastline. There are so many different technical terminologies on this, which are self-explanatory in the sense of physical oceanographies. So the moment you say waves, which are generated by wind and propagate from the ocean to the shoreline across the continental shelf. So waves for somebody, waves on the coast are beautiful to enjoy people. But as a coastal engineer, as an engineer who want to deal with the coastal infrastructures, they are violent too also. Not only they are beautiful for the people to enjoy on that, surfing and scenic beauty and to spend the peaceful time along the coast. But as a coastal engineer, these waves are waves are threatening parameters for a designer. They are violent. Okay, we have to deal with these type of wave phenomena or fluid phenomena. Basically, is a fluid structure interaction scenarios or problems you have to deal with when you're designing the coastal infrastructures like breakwaters, jetties, any marine infrastructures, offshore pipeline, and berthing structures, all these things. So, so similar to our similar to how we design dams which are a static water mass, we have a pressure forces. Then here in case of ocean, the mass is a dynamic condition. It imparts a dynamic force which is predominant, and it is very much high compared to the static water force or water mass. So these are sometimes these wave forces will also give you very high impact or impulse forces. Theoretically, these forces are called pulsative forces if the waves are non-breaking. So if the wave is breaking violently and the structures will see on this, that will give very high impulse and impact forces on the structures. So very short term and very high impulse impact forces. So that you need to take care when you are designing the structures. So, how to bring it down? This one. Okay, fine. So the waves which are generated somewhere. So yesterday you might have learned something from JD Agarwal's waves, and there are different types of waves in the ocean. But as engineer, I'm always interested only in gravity waves, which carries very high energy when they are propagating. So these waves which are generated in the deep ocean, which are called seas, when they travel to the coastline, becomes swells, and these seas when they progress or propagate towards the coastline, they will undergo a lot of undergo many processes which are called wave transformations. So these wave transformations are responsible for the turbulence and surface zone dynamics, what we normally call as refraction, diffraction, shoaling, breaking. These are the processes which are responsible for surface zone dynamics. That is why in the surface zone you have a lot of waves will be coming with a lot of foam, bubbles, then muddy water, turbid water, because these waves, water particles are interacting with the seabed because of the turbulence that creates that also creates sediment movement. So yesterday in the Sundar sir class, you might have learned about the sediment transportation, which are longshore sediments and cross-shore sediments. Longshore sediments are the sediments which move. This sediment transport, if it is carries more sand away from the site than towards it, which results in the beach erosion. That is a normal definition, normal understanding of the erosion, coastal erosion. The moment you say coastal erosion, it is a beach erosion or sand erosions. The beach is depriving of sand, and there is a deficient of the sand on the beach. So the question we used to teach our students that why a wave needs the beach, or why a beach needs a wave. So when we learning with Sundar sir is my teacher. When we are learning with in our PhD program, he used to say that waves and beach and waves are both husband and wives. They have to complement each other. Waves needs some cushion to dissipate its energy, and that is beach, or some energy absorbing media is required for the waves to dissipate its energy. So that is beach. And that dissipating media is what we call as a normally, if it is a sandy coast, sand. If it is a rocky coast, we have a rocky outcrops, boulders, and sand grain sizes are much larger than the normal fine sands. That is what waves requires needs a beach. But why in beach needs a wave? So waves, when they are transforming themselves from the deep ocean to the shallow waters, and then to the surf zone, and then to the swash zone, and then finally to the beach, it will carry or it will bring the sediments along with them and deposit on the beach. So that is how these deposition slowly it happens over a period of time that what we call as accretion of the sand or sediments. And these accretion of the sediments and sands forms is a beaches, sandy beaches. Am I audible to you?
Yes, sir. Yes, sir. You are audible.
Fine. So this is how these two, beach and waves, has to complement each other. One is they always has to interact with them continuously to sustain themselves. And there is the very important term what we call as a dynamically stable equilibrium or dynamic equilibrium. So this dynamic equilibrium is reached when the waves and beaches are satisfying themselves with basic requirements. Means the energy is successfully dissipated on the beach, and the beach is receiving the required sediments on its along the shoreline. This is what we just I was telling you, the wave transformations. This you might have learned in the previous classes. Then the nearshore sediment transport and the coastal processes. This is what we call as a longshore sediment transportation. I told you the waves, when it brings the sediments, they approach with some oblique angle. So waves never come and interact with the beach exactly perpendicular or right angles to it or perpendicular to the shoreline. But they always come with an oblique angle, certain angle to the beach. So when this is waves are moving with angle, the momentum has two components. So it has horizontal component and vertical component. The horizontal component is called as a longshore sediment or longshore drift, which what normally we call as in a coastal engineering terminology, mass transport. Most of the time, the moment we say waves are moving, so the people used to understand that water is moving. No, the energy is moving. That is how you should understand the propagation of the waves or propagation or movement of the waves. And the velocity with which these waves are moving is called as celerity. So this if it is solid particle, we call as a speed or velocity. But the waves, when are moving, it is called by its celerity. C is equal to L by T. But inside the waves, we have water particles, which are very important in understanding the mass transport. So water particle, there are infinite number of water particles. If you say one particular cross section or water column at a given section, so it will have horizontal velocity component and its vertical velocity component. So horizontal velocity component, in the sense it is parallel to the coastline, and that what we call as a longshore sediments or longshore drift, which is responsible for moving the sediment from one place to the another place. So this movement of the sediment is always continuous. So it depends upon the direction of the wind, and in other words, direction of the waves. So in one particular season, this may be moving from, let us say, south to north, but especially in Visakhapatnam, our net sediment transport is from south to north, from Chennai towards the Paradip. What is in particular season. In another season, when the wave direction is changing, the littoral transport direction also change, or sediment movement also will change. But the net sediment transport is very, very important. That decides whether the coast is eroding or accreting or depositing. So there are evidences that in the east coast for the past, 20 years, it is continuously eroding. And the erosion rate of recent past is very increased compared to the previous decade. So it is the alarming rates. The erosion process, the rate of erosion is at alarming rate. The policymakers or government authorities or municipal authorities has to be cautious when they are planning infrastructures along the development along the coastline. So the states which are abutting to the coastline or along the coastline, the municipality engineers has to be well informed, well trained in this process. So many of the conventional municipal engineers which are recruited about 30 years back, 20 to 30 years back, they are conventional civil engineers. We are for the past 10 years, we are facing this problem. Many of these engineers have very little knowledge, idea about these coastal processes. So the moment they say the coastal erosion or eroding some part of the coastline, they simply bring the stones, dump there, thousands of trucks. But that is not the solution. So we are trying to educate them. I'm also trying to. I have given a couple of training programs for them to make what do you call as a capacity building of the engineers who are looking after the infrastructure development on the coastline. So that is what about littoral transport along shore or long shore treatment. Then there is another the vertical component or perpendicular to the shoreline, which is called cross shore sediment. Sorry, cross shore sediment transportation, or it is also called onshore offshore. Onshore means towards the shore, offshore means away from the shore. So always this, when the wave is moving towards the coastline, you have a vertical, the perpendicular component or vertical components is onshore. When one wave reaches the beach, and then it has to come back. So when it is coming back towards the sea, so this again it will bring the wave, bring the sum of the sediments again back to the sea. This is a continuous process. And at certain point of time, it will reach a dynamic equilibrium. Whatever you see at the present, say, is a beach status condition of the beach is the dynamic equilibrium condition where you have a stable beach. So our aim as a coastal engineering has to see that the beach is stable in a given time scale. So these horizontal and vertical components will drive the sediments because it creates a currents. So it is called longshore currents, cross-shore currents. You see the waves are always approaches the coastline with some. If you see this is the coastline line, draw a line here parallel to this, and draw a line along this coastline. The wave direction. Then you have a angle on this. This is what we call as a wave approach angle along the coastline. So when it comes to, I told you we have a coastal erosion has a term, has a definition, different definition for the different people. So you can define the coastal erosion in many ways. So every word uses once apart from off, which is used twice. So if you say erosion, how do you define the erosion? Erosion is veering away of the land, or erosion is veering away of the beach material, or by the action of the wave. So this is how the combination of the words you can use for the different definitions of the coastal erosion. So the coastal erosion happening because of the two reasons. One is natural phenomena or natural events such as cyclones, then storms, then tsunamis, then wave action, tidal actions. So similarly, we have the second category of the coastal erosion is anthropogenic or man-made actions or activities which are continuously happening in the name of development along the coastline will also trigger the coastal erosion along the coastline. So in addition to these two, natural and man-made, there is a third parameter which of late where people are discussing rigorously about this is the climate change. So climate extremes, I don't know whether this climate change will come under the natural cause or not, because still we have for the last during my studies we never come across the word climate change or climate change impact, climate change resilience, disaster risk resilience. So that is why it is a question whether should we include the climate change in the natural or not. So, but still, climate change is happening. It is happening. So, climate change shifting frequency and intensity of the hazards. If you see if it is the chronology history of the natural events which are happening along the east coast and west coast, is increases compared to the previous decade. So, in Vizag, we are receiving on an average 2 storms or cyclonic events in a year. To tell you one of the that during 2014 Hudhud cyclone, before cyclone on that day, before that day we were doing a beach survey in the RK beach, and that night there was a cyclone, and immediately next morning we are at the beach. So that is a great opportunity for us to exactly measure the realistic data. What is the impact of the cyclone on the coastal erosion? So we have a very important, very valuable data collected just one day before the cyclone and immediately next morning of the cyclone, Hudhud cyclone. That project was sponsored to me by NIOT, National Institute of Ocean Technology. The entire data is submitted to that. Okay. So as a coastal engineering, I may not be interested more on heat exchanges, heavy rainfall, droughts, but I am more interested in sea levels. So the sea level is causing trouble to the coastal engineering or design as of late. And during the course of presentation, I try to explain about the impacts of the sea level rise on coastal infrastructures. Okay. So at the end of the day, we have to design an effective climate resilient disaster risk reduction management system for the coastal erosion. So that is what we are looking at as a efficient, good coastal engineer when you are designing a coastal infrastructures. So in India, India is highly vulnerable to the natural and anthropogenic disasters on account of the geoclimatic settings. So these are some of this. It has so much long coastline, but the most of the time, very commonly happening event, natural event, the cyclonic hazards. People may be from Pune may not be feeling the heat of the aftermath effect of the cyclones, but on the coastline, my house is very close to the beach. We feel every time, we feel to scare that every time the cyclone is coming. So enormous. I'll tell you the impact of the cyclone is. I parked my car in my compound, and I forgot to put a handbrake. During the cyclone, my car is moving back and forth according to the direction of the wave. Then immediately I used to tie with the car with the chain, iron chain to my gate there in that one. So that is a huge impact on wind velocities and corresponding corresponding beach processes on the coastline. So I'm just concerned about cyclonic hazards. So now the question is, you had a we accepted that there is erosion, and erosion cannot be stopped. It is a natural process, and it has to go, and it will be there. And Professor Sundar sir used to say that whenever we approach him for some advice, he used to say erosion is a cancer. You cannot treat it. You have to live with it. So coastal erosion is a process. We have to live with it, and there is no solution for permanent solution. Only you can tame that. You can reduce its intensity to protect some important, very, very critical and important infrastructure along the coastline. So that is there are so many management techniques which are called short-term management techniques, medium term, then long term. Short terms are anybody can do this with common knowledge. Short-term protection. I told you the GVMC authorities will simply they bring hundreds of trucks of tons, stones, big stones, which is about 1 ton, less than 1 ton stones. They simply dump on the coastline to protect temporarily for a week or 10 days, so that the government will take the policy, and they will call the tenders for the permanent solutions or the long-term solutions. Once you settle for the long-term solutions, and you have taken a decision to construct or protect a particular coastline, and then you have the coastal manager or coastal management systems has to look for the various alternatives. So what are the various alternatives? What are the protection structures, coastal protection structures that are being using over a period of time across the world? And also we are also following similar trends, similar procedures, concepts in Andhra, in India also, along the coastline. So coastal engineering is the study of the processes ongoing at the shoreline, construction within the coastal zone. The field involves the aspects of nearshore oceanography, marine geology, civil engineering. All these are often directed to all these specializations are specialists or technocrats, engineers, scientists. All together all of them has to come together to combat only one enemy, that is coastal erosion, eroding the coast. Coastal erosion, I will give you the best example of what is the importance of the coastal erosion. In Shanghai in China, they have a 14 kilometers stretch of petrochemical complex corridor, and it was constructed seawall was constructed to protect that complex, 14 kilometers sea walls. And then over a period of time, what is happened is coastline is coming closer and increasing towards the land side, increasing or encroaching the land mass. Now the question, now the safety of that petrochemical complex is under question. So seawall alone cannot protect that. Now people are now looking for an alternative solutions to protect the existing protection walls, existing protection infrastructures or protection structures. So those structures, earlier structures were constructed without much considerations on the sea level rises, extreme events, and also another important point is these properties are well away from the coastline. So about 500 meters or 700 meters away from the coastline. So that time they might have given a little importance on these extreme events, sea level rises, and coastal erosion problems. So similar problem also we have in I'll show you that one of the field example. Hello.
Yes, sir. Now you are audible.
Okay, fine. Please move this window away from the shade. What should I do with this? Okay. Okay. So, so this coastal zone is a very important and is also a very dynamic zone. Though it may be very small zone about less than 100 meters, but is a very critical and very important for the sediment transportation and coastal protection activities. Let me see. Let us look it. What should I do? This is
You
blocking
remove
this screen.
that block from the shared screen.
Oh, now it's gone. Okay, fine.
Now still it is showing.
Please move this window away from the. Is not moving.
No, still it is there. You can stop sharing. You move it again. You can start from that slide, sharing the screen. Okay, now it is okay, sir.
Right.
But still it is coming again.
Hearing. Okay, fine. So it looks like a similar typical coastal zones looks like this. You know this high tide, low tide, these terminologies you might have come across with previous classes. What I'm looking at, this is the area. If you see at the two-dimensional diagram, this is a typical beach profile and coastal zone. This is a seabed, thick line, and we have a waves. So there is one area called a hump-like issues here. This is called bar, sand bars or bars, which are responsible for the waves to shoal, or which causes the wave shoaling. Wave shoaling triggers the wave breaking. So once the wave breaks, it dissipates a lot of energy. So this is the point from this onwards, from this point where the wave first breaks, when they are traveling from deep ocean towards the coastline, wherever the wave is first breaking. After this, wave will undergo multiple breakings, but the first breaking from this point towards the sea, deep sea, is called offshore. And from this point towards the landmass, it is called the coastal zone. And this coastal zone is, as per our CZM guidelines, Government of India Coastal Zone Management Regulation Zone, this changes, is a dynamic. Maybe you fix about 500 meters or 1000 meters from this point as a high tide line or coastal zone, based upon this existing beach and these breakers at that particular point of time. After 5 years, 6 years, when the beach is when the beach is eroding and the water is coming close to the landmass, again this coastal zone restrictions guidelines will change. So is it changing? So as per this coastal zone regulation manuals or guidelines, you cannot have a construction within the 500 meters from this line. So if anything happens to that structure, the owner can claim the insurance for that. If it is away from the 500 meters, within the 500 meters, it is at the risk of the owner. Then let us say you have constructed that structure 20 years back. That time coastal zone, this line was different. Now the line is moving towards the landmass, and that structure which was constructed 20 years back now coming into the within the 500 meters zone. Now the question is, if at all there is a damage due to cyclones or something, what is the fate of that building and the damage costs? So that is about financials, but we are not bothered about it. As a coastal engineering, I am looking at the structures which are happening or constructed along this coastline within this coastal zone. So now in this coastal zone, I have a nearshore zone, beach, then I have a surf zone. And this is the area, most of the turbulence, wave dissipation, wave dynamics, and turbidity water will happen. So in this area, the sediments will have three parts. There is a suspended sediment load, then the load is siltation, then bed load sediments. So siltation, suspended sediments load will always be in suspension because of the turbulence. And the waves, when it is moving on the shoreline, because the shoreline always will have some inclination and some slope or gradient. When the wave is moving along this gradient, Can you see my cursor? Somebody identify my cursor. Hello.
Yes, sir.
Can you see my? I'm moving the cursor here in the slide.
Yes, cursor is
Yes, sir.
So when the waves are moving along this gradient, along this slope, at certain point of time, it becomes velocity of the wave or water particle becomes zero. So beyond this, wave cannot progress. So at this point, it will drop the sediments because the current shear stress of the is much less than the shear stress of the soil there, or the water particle does not have the capacity to hold the sediments, so it will simply drop there. So that is how over a period of time, the sediments will accrue and the beach will form. And also second point is when the wave is moving along this coastline here, it is moving against the gravity, so velocity reduces. The same water or water particle after reaching this point where velocity becomes zero, it comes back again. It is called down rush. This is run up and up rush and run down, or it is also called down rush. So down rush will have a velocity which is more than the up rush because it is moving towards the gravity. So velocity increases, and these are very, very critical. These down rush or run down wave will take all the material which are finer and brings into the suspension. And these are also sometimes what we call as a rip currents. This also forms a current, rip currents, and in addition to our longshore and onshore offshore currents. So then let me, this is having learned something about the coastal erosion. Now our aim is to protect, how to protect our coast. So there are many causes and time scales. So cyclones, tsunamis, extreme waves, sea level rises. Okay. So another very important cause for the coastal erosion is we are not giving the sufficient sand from the sand is supposed to come from the rivers and finally it has to be deposited in the sea. So, but we are damming the rivers. So we are stopping the sediments which are supposed to be joined in the ocean. So the ocean, now the beach is deprived of sediments which are supposed to come from the rivers. That is another big reason for the deficiency in the beach materials. Right. So this is one of the case. This is exactly on 2014 Hudhud cyclone. This was the before Hudhud cyclone. On the left side, you can see the lighthouse here. We have a submarine, Russian-made Kurusura submarine, and it has been there for as a tourist attraction. The people can visit this there, go inside and see the entire submarine. And it has been established there for the tourist attraction. And there is a large beach farm in front of it, about 50 to 60 meter beach, beautiful beach. People used to come and enjoy on this beach. And this is the scenario. And we have taken all this data before, one day before the Hudhud cyclone. And this is the scenario the next morning of the Hudhud cyclone. The entire beach is gone. And I have some photos on this. I'll show you that. So the entire submarine, Kurusura submarine has been damaged. Not Kurusura submarine is not damaged, but the protection wall and the inside park, everything is damaged. And the water has come inside to the submarine. There are pigs. This photo is visible to you?
Yes,
The
sir.
photo.
It is visible.
So now
Yes,
you
sir,
can,
it is visible.
this you can see there is a light post, post, and you have a pedestal foundation, and you can see this is the mark. That was the original sand up to this beach was there, and you can see the how much amount of depth of the erosion was
Sir,
happening.
it's blurred.
Hello.
Muni Reddy sir, yes sir, it is blurred now. We can see the window in blue. Is it any animation?
No, no, it is only photo.
Okay.
Okay, then what I do is now is it okay?
Yes sir, yes sir. Now it is, yes, it is visible.
So this much about more than 1.5 meters of depth of the sand. You can see this. This much sand in one night, one day have been disappeared. And this entire protection wall is supposed to be sea wall. I'll show you next. There are some other photos. Entire this is caved in, collapsed. And next to this is our Kurusula Submarine Museum. This is the photo. I was with this municipal engineers. That was the beautiful photo before the cyclone. And the engineers were visiting there, and then that was the condition. And okay, this is another area. So 11, 10, 11. Okay, fine. This is the condition. Can you see now? Is this photo is visible?
Yes, yes, it is.
So this is the scenario the next day morning in the submarine. The water have reached up to this. There is a below the sea submarine. The water reached and touched up to this production seawall. So that is the huge impact on the coastline when there is an extreme event like cyclones. So now the question is why we need to protect. Coastal structures are important assets for us. So we need to protect the harbors, inlets for the commercial and military navigation links, especially Visakhapatnam, because East Navy Command is here. So it is very critical and very strategic event. We have to protect our coast for this military movement navigation. So provide beach and shoreline stability control. That is very important. As a coastal engineer, I always has to look at my beach is stable or reach dynamic equilibrium. But reaching to get dynamic equilibrium is difficult in terms of time scales. But at least I try to see that in every season my beach is stable. Stable in the sense it is neither accruing nor eroding. So navigation, coastal communities, roads and bridges. So provide flood protection also. So these are the reasons, and these are the infrastructures I need to protect from the coastal erosion. There are solutions. There are n number of solutions for the coastal protection, but basically they are classified into two types. Numerous devices have been devised to stop the erosion process. These can be divided into two basic types: hard solutions and soft solutions. Then what are the hard solutions? So hard solutions have been traditional tool for the coastal engineer. The sea walls, breakwaters. So these are the hard solution. Means you have to interfere with the nature using these structures. These are the solid structures, and you have to interfere with the natural phenomena. And the types of soft solutions, we have a sand dune management, vegetation, which is called bioshield. And soft solutions are those that are more natural and eco-friendly. So that we have a beach replacement or beach nourishment, then we have a sand bypassing. In addition to this, recent approach is to have both. Every solution has its own advantages and disadvantages. But take the advantage from soft solution, take the advantage from the hard solution, combine this, you have mixed hybrid or combined solutions, which is beach nourishment plus groyons or reef breakwaters or offshore breakwaters. Then sand dunes plus vegetation. So this is more natural, more eco-friendly solution. Sand dunes with the vegetation. So the bioshield, so UNNP, FAO, they are advocating this use as much as possible bioshield to protect against natural disasters, storm surges. And concepts are like this. So we have a mixed solutions. As an engineer, I have to assess the performance of the each engineering intervention, how well it is performing. Performance in the sense, we have designed, let us say, breakwater or seawall is designed just to protect them. Very important critical infrastructure. Let us see, if you have in here we have HPCL. Here we have a thermal power station, Simhadri thermal power station. Somewhere you have a nuclear power stations, which are very, very important, very critical infrastructure. And there is no alternative. You have to, at any cost, to protect. Then you have to go for a solution like sea walls that will give you very strong protection for that infrastructure. Again, seawall, it has its own disadvantages, but we will look in. We will discuss that also. So there is breakwater just to protect the coastal erosion. The function and purpose is different. So functional and structural performance has to evaluate or study carefully before finalizing the solutions. That is very important. So these are the sea walls. Sea walls may be vertical, sea walls may be curved, sea walls may be step type. Sea walls just resting on the ground, sea walls may be resting on the piles. Sea wall may be just simply rubble mound breakwaters. So these sea walls again classified into non-energy absorbing and energy absorbing. Non-energy absorbing the structures, impervious, huge monolithic structures, concrete or it may be stone structures. It will reflect the entire wave energy back to the sea. It will not allow any wave to penetrate through this. So entire energy is reflected back. So reflection coefficient is 1. So the energy is not absorbed by this structure. But whereas energy absorbing structures are this, when the 1 unit of energy is, let us, interacting with the seawall, about 60% of the energy is being absorbed by these energy absorbing structures in front of the vertical structure. So remaining portion will only go as a reflection energy. So that is why they are called energy absorbing type structures. So these are see, if you see, all these are very steep or vertical phase structures. But whereas sloping seawalls are energy absorbing, sorry, when the wave is approaching on the slope, there is a condition called wave breaking condition where h by d is equal to 0.78, which is a condition. If that condition is satisfied, wave has to break, no other go. Wave has to break. Once a wave is breaking or broken, it dissipates a lot of energy. So very small energy, very small waves will again further propagate, and again it will reaches a condition where h by d is equal to 0.78, then again break. So there are multiple breakings on the slopes. So these type of sloping walls are best suited for the coastal protection for the erosion. I'm not talking about the foolproof protection for the critical infrastructure. So sea walls are the onshore structures with the principal function of preventing and alleviating overtopping the flooding of the land and the structure behind due to the storm surges and waves. Built parallel to the shoreline as a reinforcement part of the coastal profile. Sorry. Sorry. So each solution, each type of wall protection structures has its own advantages and disadvantages. If you see this type of structure, it will reflect entire energy, and the high waves are coming, it will splash over this. So this curved sea wall and this type of sea walls will have the characteristic that when the wave is moving along this, propagating along this, it reflects back. So entire energy is, this is called re-entrant phase, curved phase sea wall. The wave will go back, there is no splash. This type of curved sea walls will reduce the splashing or overtopping of the structure. Step type sea walls has another advantage that are the sharp edges. We might have studied in fluid mechanics, sharp edges, at the sharp edges there is a flow separation. When there is a flow separation, there is a lot of eddies, so energy loss will be there. So that is the principle we are using to dissipate as much as possible the wave energy. Is designed for the moderate waves. Concrete sheet pile walls used to prevent that. Okay. Then rubble mound, simple, just to put a mound of stones. Rubble mound sea walls are built to withstand severe wave action. The cover of the fronting beach may occur. The quarry stone comprising the seawall can readjust settlements without causing much damage. But where advantage of this rubble mound is if there is a settlement, differential settlements in the seabed, because these are not monolithic structures. They are individual stones, elements. So they adjust themselves. But these are the structures they will not adjust because they are monolithic concrete structures. There is always problem of covering below this. So rubble mound sea walls, curved face sea walls with mounds. Then we have a sea wall with step type sea walls. The second category is bulkheads, similar to the sea walls, but here bulkheads are built as a soil retaining structures, in most cases vertical wall anchored with the tie rod. Bulkheads are also similar to sea walls, but in the size is less compared to the sea walls. So these are just to protect the soil slopes, retaining structures for mild wave conditions. These sheet pile walls. Most common applications is the construction of mooring facilities in harbors and marinas. The exposure to wave action is minimal. So these are the different types of bulkheads: concrete bulkhead, sheet piling, cellular piling, then timber, untreated logs. So this is a bulkhead, very small thickness. Then revetments are onshore structures with principal function of protecting the shoreline from erosion. Consist of cladding of stone, concrete or asphalt armor sloping the natural profiles. This is like this, just to protect the coast from the erosion. The advantages of this is because it has a large porous voids. Whenever the wave approaches on this, the wave is trapped inside this porous structures and the void. So it will absorb as much as possible the energy of the wave, or wave will dissipate as much as possible in its energy on these structures. There are different types of alternatives for the revetments. Then groins. Groins are another structures for the primarily, these are used primarily for when there is a longshore currents. Groins functions only when the longshore transport occurs. Otherwise, groins will not function properly. It's a functional assessment, functional efficiency will be not good when there is no longshore sediment transports. Built to stabilize the straits of natural or artificial nourished beach against the erosion that is primarily net longshore loss of the beach material. So most of the time, groins alone will not work to its hydraulic efficiency or intended function, but they have to be work with combination of the nourishment, beach nourishment. These are the groins. About this, you might have learned the last couple of days. Sundar sir, I might have told you many of this. So the longshore sediment transport, this will happen here. This adjusted store line, this is eroded material will deposit here. This is when the wave action is in this direction. Let us say when the wave action is coming from this direction, the process reverses here. There is erosion here and there is a deposition here and there is erosion here. So this changes, shifts its direction and deposition erosional process. So they have based on the permeability, height of the profile and material. So permeable, impermeable gradients based on height of the profile, classified high profile, low profile systems. In most cases, gradients are sheet pile or rubble mount construction. Most of the time in India, the gradients are constructed as a rubble mount structures. So this is another important thing is gradients are constructed perpendicular to the shoreline. Sea walls are constructed parallel to the shoreline. That is the distinction between these two. So this is deposition, erosion, then deposition, erosion depends upon the wave directions. So always see in the field, gradients be constructed, it cannot work. It has to be a field of gradients. A field of gradients. So maybe around 5, 6, 7. Depending upon the length of the coastline you want to protect. We call as a cell between these two gradients, we call as a cell, where the cell, sediment cell concept to calculate the sediment budget along the coastline. Breakwaters, so we have a offshore breakwaters or submerged breakwaters. Most commonly applied type of breakwater. In its simplest form, it is rubble mount stones. Homogeneous stones are large enough to resist the displacements. These are the different breakwater structures. So it has a multi-layers. You have a artificial called armor layer. Then you have an under layer. Then you have a core. So it is a multi-layer structure. The breakwater is constructed with multi-layers. So it is like this: a primary layer, then secondary layer, then core. So offshore, please, one more important thing is here, all the breakwaters is constructed such a way that conventional breakwaters are constructed such a way that one end is connected to the shore, another end of the breakwater will be in the waters, deep waters. Or it may be shallow, or it may be subzone, or it may be in the shallow waters or in the deep waters. So invariably, one end of the breakwater has to be connected to the shoreline in conventional breakwaters. And there is another different breakwater is called detached or offshore breakwater, where both ends are not connected. Both ends are in the offshore. See, conventional breakwater, when you construct perpendicular to this. So one end will be here, another end will be in the water. But in the offshore breakwaters, these are like constructed like parallel to the shoreline with the segmented constructions. So it looks like this. Usually offshore breakwaters are usually shore parallel structures located in water depths 1.5 to 8 meters. For deep water conditions, these are not it will not work efficiently. It is suitable for open ocean exposure. Offshore breakwaters not only used for shore protection, but also to provide harbor protection. You are allowing the water to mix with this coastline and then come back. So you see that exactly opposite to this, there is a beach is progressing towards the this. So when this beach progression attaches this, that is called tombolo, like this. So this still has to reach. This is already reached. So this portion of the coastline is protected using this offshore breakwaters. And it acts as a sea. You can see the natural swimming pool. So gradients always will not be. So this is Guyana and this is offshore breakwater. So sometimes this combination of these two will work. But if you see the combination means don't confuse. The combination both has the hard sections. And you see the T Guyans. So this offshore breakwater and I have a Guyana. So this is how there's a different alternatives, different configurations for the construction of the breakwaters. And this is another very important, not commonly used in India, but it's very effective breakwater system, which is called semicircular breakwater. It has its own very good advantages compared to the conventional breakwaters. Well suited for shallow water situations with intensive wave breaking due to the dissipation of energy, both the wave forces on the caisson and the wave reflections are reduced. This is a simple fluid mechanics concept. This is a porous structure. When the wave interacts with this, because of the porosity and the openings, wave will be trapped inside. Inside this breakwater is a hollow. It is not the solid. It is not the solid structure like vertical sea walls or rubble mount breakwater. They are not. This is not the solid. So this is a hollow section. Means you can save a lot of material if you, for the same condition of the wave condition to protect the coastline. If you go for the construction of a rubble mount breakwater, if you have, let us say, volume V1, so much volume, for example, it may be 10,000 meter cubed. For this 10,000 meter cubed of the material, if you use this type of semicircular breakwater with a hollow section, it may be around 1,000 meter cube. So you have, because you are saving the material because of the hollowness. So, and also the shape will also have the advantage that so wave forces, because energy is dissipated, wave forces will be very less on this compared to the seawall. In the seawall, wave forces are very huge because it is not absorbing or it is not dissipating any on this. So this structure has good stability, low cost. Lateral wave forces are smaller because when the wave is acting on this inclined surface or curved surface, if you resolve into horizontal and vertical components, vertical component will be very less. So that is what lateral forces is very small, and the stability is against the sliding is very high in this semicircular breakwater. We have tested in our laboratory this semicircular breakwater, but in India it has to come up. But they are using in Japan, Miyazaki port in Japan. So we have done the experiments in our laboratory with the different porosities, 0 porosity, 10% porosity, 5%, 15% porosities. This is how we tested in the laboratory. Okay, so this is about hard solutions. Then the second category is the soft solutions. So soft solution is non-structural methods for coastal shore protection. And the examples are vegetation planting is an effective and inexpensive way to stabilize the dunes. One of the example in Visakhapatnam is many of you may be knowing the Visakhapatnam steel plant, very big in South India, steel plant. So their property is because they are getting water from the shore and is very close to the shoreline, place called Appikonda. So these their property and compound wall is protected with the casuarina trees. They planted number of thousands of hundreds of casuarina trees along the shoreline in front of their property. So vegetation is also inexpensive and natural way to stabilize the sand dunes because already sand dune is existing there. In addition to that, they also planted casuarina trees. So this is a mixed type combination of sand dunes and vegetation. Another alternate solution is beach nourishment. Beach nourishment is also a very effective solution, soft solution compared to the hard solution. In the hard solutions, people will hesitate to move into the beach because you are constructing with rubble mount. Let us say if you take, for example, Groyans, you are constructing perpendicular to the shoreline, there will be a lot of rock mass. So people may slip or there is some slip on this, and there is some accidents along the people when children's for old people when they approach the coastline. and also hampers the aesthetic beauty of the beach if you introduce or interfere with the hard structures. But in the case of beach nourishment, such disadvantage will be overcome. So you have a beautiful scenic beauty, you have an easy approach, natural sand, but only the disadvantage is you have to do for a maintenance beach nourishment regularly. So that is not happening in Indian scenario. Visakhapatnam, after construction of the Visakhapatnam port, on the south side there is a huge deposit beach formation. There is a what you call beach is reclaimed. On the north side there is a large erosion. Huge erosion is happening. What they did is, I'll show you in the next one. They did the sand bypassing method. So wherever there is a deposition of sand, you pump the sand wherever there is a deficiency. So they did the sand bypassing and beach nourishment. They did beautifully up to 2012. After 2012, there is some maintenance expenses are increasing to the budget of the port. They discontinued that process. The result is every year huge amount of beach we are losing in Visakhapatnam. Then flood proofing. One of the most common flood proofing measure is to the elevation of the homes. I'll show you this some of the examples. Then zoning, retreat. In some cases, it may be less expensive to relocate the endangered structure than to invest large scale protection. You have to retreat, allow the beach to interact on its own naturally. Do nothing, no action or do nothing approach is commonly used by engineers to help evaluate different courses of action. So artificial nourishment is bringing the sand or sediment material from the offshore, which is called spoil grounds, waste energy dissipators. Erosion problems occur if there is a deficiency in energy supply front. Artificial replacement of borrow material on the eroding shore is closer to working the nature. Only problem is periodic replenishment is the problem. See, every year the cost of dredging and pumping and placing the sediment on the beach will escalate. So the cost and the rates will be higher. So maintenance is a problem in case of artificial beach nourishment. Otherwise, it is a beautiful solution. CWPRS is given this beautiful solution to the Visakhapatnam port and the Ramakrishna beach where you have just saw this submarine. They have given this, that was the best solution to my knowledge till now. Only the problem is, it was working beautifully with the periodic replacement, periodic sand nourishment. After once the maintenance replenishment and maintaining nourishment as cost increased, expenses are increased enormously, so they discontinued it. So on the second point, disadvantage is it is very important to select the suitable borrow material. So you have to assess the what is the existing stable beach size of the material. You have to bring the same similar size from the borrow material. Either it may be offshore or it may be another place where it is deposited. So most of the time we will not get the same size. That is the problem. Because when you dredge it from the offshore with the dredger and bring it back, it will have all the sizes. So if you dump 100 units, out of 100 units, about 50 to 60 units will go back because of the sediments, which may be less than the size of the already existing size of the beach material. So beach borrow material with the same grain size distribution as the negative material is most suitable for the fill. Native material is most suitable, but most of the time we will not get. So that is the problem. If you want to dredge, let us say 500 meters by 10 meters, 5,000 cubic meters, you have to do about twice, bring the material twice that of the material, because borrow material will have all the sizes. Let us say existing beach size of the sediment, it may be 2 microns. You will get the borrow material, it may be more than 2 microns and less than 2 microns also. Only the material which is more than 2 material will remain there rest of the thing again will go back to the sea. So next, another natural soft solution is you go for the vegetation. So there is another important people are now using is submerged reefs or submerged dikes or submerged breakwaters. You put below the on the seabed, below the sea level, below the SWL or MSL, mean sea level, a submerged dike or submerged breakwater instead of emerged breakwaters. So emerged breakwaters means above the sea level, above the mean sea level. Submerged means below the sea level. They are also called low crested breakwater. So my entire PhD was on these low crested breakwaters. So the advantages of this is it has to operate on a condition that when h by d is equal to 0.78, wave has to break. So these reef will reduce the water depth. So that triggers the wave exactly over this structure. Once the wave is broken, there is a smaller waves will propagate. So less energy. So with the less energy, it cannot erode the coast. That is the idea. Another one is you go for the vegetations. It may be seagrass or it may be casuarina trees or mangroves. So it also natural protection like this. So we have done this experiment, this in research in our laboratory. We have a wave flume of 45 meters length, 1.25 meters width, 1.25 meters depth. So we have done this. So these are the natural mangroves vegetation. So this is what I was talking. We have done the experiments with flexible vegetation, rigid vegetations. So videos are playing.
Yes, sir.
Can you see this? So we do this. So this is a flexible vegetation, seagrass, and we have rigid vegetation. With this rigid vegetation, we simulated the stems of the mangroves. At the bottom, you can see we have done the experiments on semicircular breakwater system.
So third one is not visible. First two, yeah, the one where you are having cursor right now.
It is a semicircular breakwater. It's not visible.
Yeah, that's just dark slide we are seeing.
These two are, you can see, right? Flexible and rigid vegetation.
Now it's other way around. In fact, the slide which you are showing now, the third one is visible, sir.
Video.
No,
also. Video.
No, I'm not able to see. What about others? Anyone can just.
No, it is not.
Yeah.
It is not.
Yes, it is
So
not
now,
visible.
Video is not playing.
No, sir.
I think I have to share, right? DPU semicircular. Now, is now video is playing?
No, sir. No, sir.
No. I share this site. Share. ATAL University semicircular. No.
So dark slide is there.
Okay, fine. Let us not waste with that one. So we have done with semicircular also. Semicircular breakwater also we did. One of my first PhD scholar did on that. So coming to the submerged reefs, so you can see the submerged reefs. It will not, advantage of this submerged reef is it will not hamper the scenic beauty of the see. It can also will not hamper the people approach. People can easily approach, they cannot see this. But one of the advantages is when the wave comes over here and there is a braking condition which is h by d is equal to 0.78, that mechanism or that condition satisfies here, then wave will be wave is made to, and this submerged breakwater will trigger the wave breaking. So wave will break. So this is another example. So submerged breakwaters you can construct either with a rubble mound or it may be geotubes. So this is what they did, the NIOT did in KPK, Kadalur Periykuppam in Tamil Nadu. So they are using the three geotubes configuration is minus 3. Water depth is 3.5 meters. Okay. So the same concept was given to on our Visakhapatnam also by NIOT. So this is after constructing the this is the submerged breakwater or submerged dike. People also call this is submerged dike. So the waves are breaking. So broken waves with smaller amplitude will reach here, so it will not erode the coast. So then next one is beach nourishment, nourishing the beach. So there are two methods, rainbow technique and the shore face measurement. Rainbow technique means you have to pump using the dredger from distant onto the shoreline. And the second method is shore face beach nourishment. Exactly, you just deposit or pump the sand exactly onto the beach using, see, I have a dredger through the pipeline. You can see this photo. Photo is visible to you?
Yes, sir. It is
Yeah,
visible.
yeah.
So this through this pipeline, I am just exactly putting the sand or nourishing the beach where it is eroded. So this is how the this is the outlet of the pipeline. Those exactly put the sand on the beach. So the over a period of time, people have realized that rainbow technique is not much effective, because when it is throwing the sand onto the some of will fall into the water and some may be on the beach. So it will not reach the place where it has to be pumped because of the draft limitation of the ship. Ship cannot come close to the shoreline because it required minimum depth for the ship to operate. So that is why this is this is not much effective. As we saw in our case, Visakhapatnam, so they discontinued the rainbowing technique. They adopted this. He is the collector and he is the World Bank. I'm also the coordinator for this project. I was coordinating with the World Bank experts. So we were there on the beach during that time. So they are directly putting the sand wherever there is a erosion onto the point. So that is why this is more effective than the rainbowing techniques. So this another method is sand bypassing. So wherever there is sand is accrued or deposited, let us see in this case, you take the sand here from this pump through this pipeline and to this side. So this protruded landmass will act as a groyan. So this side is deposition and this side is erosion. So wherever the sand is deposited, you can take this sand and pump onto this place where it is a deficiency. And this is another example, sand bypassing. So this side is because these two are acting as a jetties or groyan. So there is a lot of deposition here and there is erosion here. So what they did is they are just taking the sand from here and pumping onto this side like this, sand bypassing to replenish on the down current side of the jetties. So they are depositing here. This is another this is another very good solution for that. This is been there in the Pondicherry. We were there when I was doing PhD in IIT Madras. Sundaragowda sir and my guide, we went there for the site visit. Those time Dutch people have done the below this channel. This is approach channel where the ship has to fishermen boat will go inside the harbor. So below this channel they constructed a siphonic tunnel like pipe. So they used to pump the sand from this side to the other side. So these are what we call as a flood proofing, which is also disaster resilient systems, because elevated constructions. So normally when there is a flooding or wave action due to cyclones, will pass the all water mass will pass below this structure. So the people who are living above this in the elevated places will be safe. So they will not be impacted by the water which is flooding in the ground. So this is the school building. This is not elevated. So people are moving on to the rooftop. So then they did like this. So below this, water will move without touching to the people and its occupants. This is another very good. I mean, it is not conventional. As far as to my knowledge, the solution is not conventional. It is unconventional solution. There is Ennur Express in Tamil Nadu. So it is. There are two ports, Chennai port and Ennur port. So Ennur port is constructed just only to import the coal from Australia for the running of power plant, which is called North Chennai Thermal Power Plant. And coal is there is a highway, and the highway is being damaged because of the wave action. You can see half of the wave national highway was taken or eaten away by the wave action. Then what they did is they approached this solution. What is this? These are the hume pipes, concrete hume pipes, which are supposed to use for the drainage system. So there was hundreds of pipes are lying idle in Chennai. I don't know why they have brought this. Maybe one government might have brought this for some UZD underground drainage system. But when the next government may not be using this. So these pipes were lying idle. So what they did is they brought here filled with the concrete inside it, then they put on the shoreline. it cannot survive even 1 month. What is the problem in this? It is like vertical seawall caissons, but it's just they put on the seabed. There is no proper foundation for that. So what they thought is, because of the self weight, like a gravity action, it will be stable for the wave action, but it is not so. What will happen is, whenever there is a structure on this, when the wave acts, it scoops up the material in front of it. It scoops up the material like this. So what if, let us say I have a structure here and the wave is acting in here on the front side, on the sea side, there is a scouring. So once this covering happens below this, what will happen? It will simply tumble, then fall onto the seaside, and one by one, all the pipes will fell onto the sea, inside the sea, because of the covering in front of this structure. So that was not. So this is a temporary solutions. It may be there for 1 month or 2 months, but it is not the permanent solutions. So this we have already discussed. So a hard solution interfere with the coastal process, and the soft solutions will be using the natural processes. The question is, many people last time also asked to Sundar sir, which solution is a better solution? So we cannot give you a solution, particular solution is the best solution for the coastal erosion. No, it depends upon the location. These solutions are site-specific solutions. There is no unique solution for a coastal erosion, and also depends upon many parameters. Cost, choosing which method of coastal erosion is most appropriate for an area of coastline may take into account the cost, lifetime, environmental impact, sustainability, and most of the time availability of the material for similar crafts. This is the point. This is the parameter which made to discontinue the beach erosion, beach nourishment in Visakhapatnam. So they could not get the correct proper material for the beach nourishment. So availability of the material for, with the similar characteristics. So that depends upon all these parameters to choose in a particular solution. Most of the times we have to go for via media, sacrifice something, gain something. So this is about, we lost about 2005, 50 to 60 meters. So 2005 shoreline was here, 2011 shoreline was here. You can see the submarine, Kurusura submarine, and there is a highway on this. So we did all this field survey. They have given the consultancy work to the Andhra University. I did it. So they have given a solution is perched breakwater. So submerged reefs or submerged breakwaters also, some countries they call perched breakwaters. So it is at a distance of about 220 meters from the sea in the RK beach, where we have a Kurusura submarine museum. So this is also another important important case study. What we did is a land substance. This is a place called Vodalarevu, where ONGC has a processing plant. You can see the white buildings here. In the deep sea, where they have a ONGC offshore drilling platform, they used to drill the oil, pump to this processing plant. After processing, they will be exporting. So these are the wells you can see here. So these wells, once they were on the land, so this is about, you can see the plant is here. These were about more than 1,000 meters, means more than 1 kilometers away from the plant when they were in operation. What happened is over a period of time, there is a, because of the exploitation of the oil in the ocean, what will happen? So whatever the amount of volume of the liquid you exploit, the same amount will sink inside. So land substance. When the land substance, the water mass which above will move further. So that is what happened. So that reached this land mass, this water has reached up to these wells. So after that, what they did is they decommissioned it and capped it. They decommissioned it and capped the wells. So they now abandoned this. So now problem is, that is one problem. So they have lost the precious oil wells. And the second problem is, if the same continuous, the same water encroaching or ingressing into the land side continuous for next 10 years, it may reach up to here, very close to their processing plant. So about 15,000 crores investment is here. And the question is, if the same ingress of the water, ingress of the waves into the land and towards their processing plant happens, what is the scenario after 10-15 years? So these are the officials from there. So I was also one of the member in that committee. So we did it. Finally, this work was done by the CWPRS. So as myself with NIOD, initially we started this work. After that, there is a change in the administration. Then finally, it went to the CWPRS. They did it. Okay, so this is another very peculiar problem in coastline. There are many number of coastal problems. Each has its own characteristics. So another climate change adaptations, you have to adjust, either retreat, abandon this, and adapt the shorelines, or defend using submerged breakwater system if you want to protect any coastline. So another important is there is a sea level rise. Originally, this was the structure. Once the sea level rises, what will happen? These structures was designed for non-overtopping structure, because that time they have not considered the sea level rise. So if there is a sea level rise, what will happen? The water level will increase. So there is all possibility that wave will reach under the land mass. So the condition is option 1, design for today and provide a new structure later. This is the condition. Option 2 is design for anticipated SLR, sea level rise at the beginning itself. Those days, sea level rise was not much into the prominence. So the people, designers did not consider that. Now, new structures, they are considering it, the sea level rise and the impact of that. Then the size, the rocks for anticipated SLR and include the additional stones. So whenever required. So first and 3 is, so design today for today, provide a new structure later, or design today, provide a additional stones on the structure for the protection of the existing infrastructure. This is one. Then functional, this is a structural design. Then functional design is same thing. You have a design for today and built a new structure later. Design for the antipest SLR in the starting, which is not possible because still we are not clear that at what rate the sea level is rising. So sea level SLR is different from different countries, different locations, different states, different coastlines. So that is a problem. So these are the altogether different protection structures: submerged, emerged, groyans, beach fields, revetments, seawalls, artificial roads. Okay. So I think with this, I conclude my first part. If the coordinators allow me a few more minutes, then I'll go to the sea level. It's okay. Shall I stop here?
Over to you, Ashwini.
Hello.
Yes, sir. Yes, sir.
Shall I stop here or go to the coastal reservoirs?
So if any questions are there from participants, Ashwini madam, you can
Yes, sir.
take the questions which are on the first topic, and then we can go for next part.
Okay. Okay. Yes, ma'am. Sure, ma'am. I request Veena Bellari ma'am for the question answer session of the first part.
Okay, ma'am. Sir, there is one question from participant. How do you define minimum permissible erosion rate and what are its parameters?
Minimum permissible erosion rate. So we need to do that. We assume and design the structure there is no erosion. Erosion will not be possible. And if it is all, you are taking the what we call as if the structure is there, then you have to consider the cover, which is nothing but erosion of the sand material. So minimum erosion is depends upon the wave action and the slope of the beach or beach slope or gradient and the sediment sizes.
Thank you, sir.
That is side specific. We cannot say the minimum is for the entire coast. That depends upon the coast to coast and the site specific conditions.
Okay, thank you, sir. One more question from the participant. What is your comment on responses of eastern and western coastal regions of India under a global and local scale, sir?
Very good. So eastern and western coastline. So west coast may not be much possible, much problem, but east coast is more prone to the global climate change scenarios. That is my answer.
Okay, sir, thank you. And in that only, another question is that what are its causes?
Causes.
In same question only they are asking, what are its causes?
Causes for global rise scenarios.
Yes, sir. Yes, sir.
Maybe, I don't know. I don't know much idea about that.
Okay, okay, sir. Thank you. One more question is there, sir. What are the steps to curb sea erosion?
Steps to curb the erosion. So first and foremost step is let the nature as its own play in the beach. So beach, you should not disturb the dynamic equilibrium of the coastline. You see that as much as possible, dynamic equilibrium at that particular location is not disturbed. Then you can go for the developmental activities.
Okay, sir. Thank you, sir. One more question is the last question, sir. How can we reduce the flanking erosion due to breakwaters?
Continue erosion.
Yes, sir. Yes, sir. Due to the breakwaters, how to reduce it?
Breakwaters will also, one side of the coin is breakwater will protect the coastline. And the other side is below the breakwater, you have again cover or erosion. So are you talking about the beach or erosion below the breakwaters? So below the breakwaters, there will be erosion because wherever you put a solid structure in the coastline, there has to be a cover or erosion around the boundary, means around the structure. You have to go for the protection measures for that structure. That is my answer.
Okay, sir, thank you. Okay, I think all are clear with your doubts. As more question cannot be accommodated here due to the time constraint, participants can mail to the coordinator and sir will answer as per the convenience. Is it okay, sir?
Yeah, that's fine. There is no problem. Okay.
Okay, sir.
So I think we can go ahead. Yeah, we can go ahead.
I can go. So this is some joke on sea level rise. Okay, fine. These are the scenarios. This is we are doing a lot of field work in the coastal in the Visakhapatnam coastal erosion problems. Okay, so it will not take much time, just 10 minutes. I think by before then I will complete that. Madam, is this okay? Is visible to you?
Yes, sir. Yes, sir. It is visible.
So coastal reservoir is another concept. It is unlike our conventional reservoirs, where are inland reservoirs. So these are some of the, general information, but I'd like to skip on this. Land. Why coastal reservoirs? So coast availability of the surplus water or the outlet of the reserve, no land submergence. So in conventional reservoirs, if you go for the dams, large dams, there is a lot of problems with the local people, lot of submergence, inundation problems. You have to vacate villages, thousands of people, land acquisition, displacement of the villages. So those problems will not be here in the coastal reservoir because of the very less habitations along the coastline are very close to the shore, sea. So minimum diversion flow in the river, which is less impact. Environmental damage is very minimum. Zero risk due to the failure of the coastal reservoir. If there is land-based reservoir is damaged, there is a downstream people, downstream properties, downstream area will be at the risk. It may be villages, agriculture fields, other any infrastructure. So there is a lot of problems with the downstream people. But coastal reservoirs, it is next downstream is only sea, no problem, no risk due to the failure of the cost. Cost of construction relatively low. Land reclamation is not required. Promotes tourism and freshwater aquaculture. So the coastal reservoir has a minimum environmental impact on the ocean ecology. So this is the crux of the entire coastal reservoir. So you know, how many of you know this is a hydrograph? We have a base flow. At the peak in the hydrograph, this is a very small portion of the hydrograph, huge discharge from the rivers in short span will come into the join into the reservoir. But when the reservoir is full, it reaches the HFL, high flood levels in the reservoir, or maximum water level in the reservoir, you have to send it to the downstream using the spillways, through the spillways. When you send or discharge or outlet through the spillways into the downstream, finally this water has to, thousands of meter cubes of water has to be reached in the sea. which is otherwise going waste. So now our idea is to tap this unnecessarily going, wastely going water, tap this water, store this water, use this water for the useful purpose, exactly at the point where the river is meeting the sea. That is why we call it a coastal reservoir. So it is like this. So on the sea, you have a river is joining the sea, and I just want to construct an abstraction here. So it will store this. So this storage is only this excess water, not the entire full water. Only this excess water which is supposed to be discharged down through the spillway during the floods. High reason. So that much want to water which is otherwise it will go there wastely join into the sea. But we want to store this, protect in the, so that is the concept first started with the first generation of coastal reservoir. The second generation of the coastal reservoir is many of the rivers are polluted because many of the industries are established along the river bank, so they will pollute the water. So in normal days, we don't store the water because in normal days all the polluted water will come and join to the sea. During the floods, only the rainwater or runoff, which is not polluted, discharged through the spillway from the reservoir, which will come. So that we will tap using the some gate provisions here. Otherwise, the rest of the time it will go and as usual it will join into the sea. In the first case, what is the problem is if you dam here, if you construct a barrier here, it will collect all the water during the floods, during the non-floods also, during normal season also. Normal season there may be polluted water. So that polluted water again will pollute the storage water. So later the disadvantage people have realized that this has a disadvantage. So after that they have come up second generation coastal reservoirs. So is a unique structure. Coastal reservoir is unique structure constructed at estuary or bay in the sea at the point where the river meets the sea to store the portion of excess water at flood times only. These coastal reservoirs and coastal wetlands to ensure the quality of water, critical role for the rural coastal population. And especially the coastal reservoirs are when the city is let us say, for example, any river is flowing through city or adjacent to city, very close proximity of the city. And if you construct the water, coastal reservoir, the stored water can be directly used for the nearby city. So example is we have a Sarada river in Visakhapatnam. One of my MTech scholar did on that, and another PhD scholar is also working on this construction of the coastal reservoirs. So it is about 40 kilometers from the Visakhapatnam city. So that stored water can be directly used into the Visakhapatnam. Similarly, there is a Mangalore city and there is a river joining to the sea. So they are also contemplating to construct the coastal reservoir where they can use directly. So many of the cities now they have a water scarcity problem that can be supplemented by using these coastal reservoirs. So concept of coastal reservoir enables major hydrological extreme, meteorological extreme to be fruitfully utilized for the benefit of the mankind, storing the river flood water in future also. So they can supply. So let us go for the challenges for every structure. There is a challenge. Though the rewards associated with the coastal reservoir is high, the construction of the coastal reservoir will also face a challenge which needs to be addressed in sustainable manner. So this is the, if you construct this is just schematical view. You divide this coastal reservoir into the sea. So one side you can use as a clear water, another side you can use as a what do you call sea level rise during that. Then you can also use as a flood protection, flood detention pools and you can also wetlands, city. So this is how this over a period of time, second generation, third generation coastal reservoirs are evolving. New concepts are evolving on the construction of this. So this is one of the solutions in Singapore. This is another South Korea. So we have coastal reservoir in India, but till now, till 2019, I also don't know. But when I invited one of the expert from the Australia, who has patented this coastal reservoir, then we come to know that we have a coastal reservoir in India, which is called Tannir Mukkam Pond. They constructed in 1974. So the Kalpsar project is new coming. Coastal reservoir in Mangalore, they are also coming up. Very short. So the Tannir Mukkam barrage in Kerala. So this is the Sea, Arabian Sea, Tannir Mukkam barrage. Here there are so many rivers, rivulets joining here. So they want to, if you dam here before joining to the sea, you can store the water. Location of barrage across the Vembanadu Lake in Kerala. They did already this. So you can also have this GBM Ganges Brahmaputra Mega River. So this is how it looks like. You can see this. So you can use these. These are all the rivers. They are finally joining into the sea. You construct a barrier here. The other side is sea. So no land submergence, nothing, no problem. If there is a failure of this dam, so downstream there is no problem of risk for any people. So this reservoir system, and you can directly during the other days fair weather conditions, you can directly discharge the water, which is polluted water, directly into the sea. Okay. So this is another proposed reservoir in Chennai in Penna River. So this is how it looks like. And then this is the gate. When you think the water is by some reason is polluted, you can also discharge all this reservoir directly into the sea through the gate and then close it. So Pala River, same concepts. Then we have a Kaveri River. So many rivers are joining at the Bay of Bengal, and there are possibilities and potential that you can tap this water. You can use this water, potential water systems. So these are different types of concepts. For these concepts are site specific, changes from location to location. You can use here. So there is another big project is coming up in Kalpsar. So they construct a dam like this. Okay. So this is about a small introduction to the coastal reservoir concept. Many of does not know about this coastal reservoir. So recently I conducted a seminar, Sustainable Storage Strategy for Water Resources Development. He is the gentleman Shu Ching Yang, is from University of Wollongong, Australia, who has a patent on coastal reservoirs. So I invited him to for the seminar, Coastal Reservoir, a Sustainable Solution to Water Scarcity. So we did that. Last thing is this everybody should remember. It is not that India is running out of water. It is that water is running out of India. This is the motto. This is the idea behind the concept of coastal reservoirs in India. So we have abundant water in India, but we are not properly capping it during the short spell of the high floods. Okay, thank you very much. With this, I conclude my presentation.
Over to you, Ashwini ma'am.
Thank you, sir.
Sir, I request our HOD, Dr. Deepa Zoshi madam, give thanks.
Thank you very much, sir. As coordinator for this ATAL FDP, I, Deepa Zoshi, head of the Civil Engineering Department at Dr. D.Y. Patil Institute of Technology, Pimpri. I sincerely thank you, sir, for your detailed explanation and in-depth knowledge sharing on the topic that is coastal protection structures. Thank you so much, sir. And I'm also thankful to Andhra University, Visakhapatnam, that because of their cooperation, you could be resource person at our FDP. And sir, I would really like to, the last message what you gave, that it is not that India is running out of water, but it is like water is running out of India, and that is why the coastal protection and all these things are so much necessary. It's really great, sir. I mean, you put it in the simple words, and so that everybody will understand the importance of this coastal engineering. Thank you, sir, for sparing your valuable time, and I hope that you will be associated with our department in future also. Thanks a lot, sir.
Sure, madam. We are working with Symbiosis University also in the Madam Kare.
Yeah.
Thank you very much, madam, to the management giving me this opportunity to associate with you, and all the participants
Yes.
bearing with me my all maybe nonsense, right? Is there any sense, something on that? Or most of things are nonsense. Okay. Anyhow, so thank you very much being with me for these 2 hours, this wonderful morning. And also thank you, Madam HOD and other coordinators and the team helping me in to do this successfully. And thank you very much, one and all. Jai Hind, Namaste.
Thank you, sir. Thank you, sir.
I welcome anybody who want to collaborate and do the laboratory, because we have in entire South India, no state government universities has this facility what I have in my laboratory. So I have developed similar to IIT Madras, same wave flume, same wave maker, what they have and what I have. But no state universities have in South this facility in India, unique facility. So some students come for their project, this Sri Ramakrishna Engineering College from Coimbatore, and also Indra Kare Madam from Symbiosis University, Pune. They also came here, but you can also do that. Right.
Yes, sir. Definitely, sir. Thank you for this opportunity. We will definitely try to collaborate and do good research work with you people. Thank you.
Thank you very much. Best of luck for the rest of the course.
Yes.
Shall I sign off?
Yes, sir. Yes, sir.
Thank you.